In the previous video, we saw what e was defined as. Now I want to use that to figure out what the derivative of natural log of x is. And once we have that, we can find some other derivatives. The first one is the oogiest one, so let's knock it out, and then the other ones will just flow right from that one. So let's start. Recall e is defined to be the limit as h approaches 0 of 1 plus h raised to the 1 over h. So I want to take the derivative of natural log of x. So regurgitating the definition, it's a limit as h approaches 0 of f of x plus h minus f of x all over h. Nothing natural log-y about that yet. Now fill in the details for this particular function. We have limit as h approaches 0 of natural log of x plus h minus natural log of x all over h. Now, if we try to plug in, we will get a 0 natural log of x minus natural log of x, so we'll get 0 on top and 0 on bottom. So we have to do some kind of jiggling to cancel out the h, or to do something to play with this. Well, I'm going to use my law of logarithms that says natural log of a minus natural log of b is natural log of a over b. So I can bring a minus together by making a fraction, like that. So I have natural log of x plus h all over x, all over h. Now, you know how I hate oogie fractions like this. I want to get rid of the h. I want to pull it out front so I can see what I'm doing. So that's what I'm going to do. So I've got 1 over h here, natural log of all that crap. Now, let's clean up the inside. I'm trying to massage it so that it looks like something I recognize, and I'm working towards something like this. But let's get there. Let's first. So natural log of x plus h all over x, I can rewrite that as 1 plus h over x by splitting this thing up. Now, ooh, this is starting to, I have 1 plus h here, I have 1 plus something. It's not h yet. Let's keep playing. 1 over h times a natural log, that comes up as an exponent, another law of logarithms. So now I have natural log of 1 plus h over x raised to the 1 over h. Now, as h goes to 0, h over x also goes to 0. The only problem is I have 1 plus crap raised to the, it's not the same thing. I need h over x here and this to be 1 over h over x. So I need to multiply by x and divide by x in the exponent so that I end up with what I want. So I will do this. So notice that what I've done is I've replaced 1 over h with x over h raised to the 1 over x. And if I multiply those together, the x's will cancel out, and I'll get back to my original statement over here. Okay, so I'm kind of crowding in the corner. Let's go to a new page. Okay, so this is where, oh, you're not supposed to see that. Oops. Pretend that's not there. So we have natural log of 1 plus h over x raised to the x over h. As h goes to 0, h over x also goes to 0. So all of this crap right here, right there, remember e is equal to the limit as h approaches 0 of 1 plus h to the 1 over h. That means all this crap is e. So now my limit becomes the limit as h approaches 0 of natural log of e raised to the 1 over x. Now I'm going to pull the same trick I did before with the exponent. 1 over x can come out front. So then I have that 1 over x times the natural log of e, and natural log is log base e. So natural log of e is just 1, which gives me the derivative is 1 over x. Ta-da! Do I have a final ta-da? Yes, I do. So the derivative of natural log of x is 1 over x. That's the long gross one. Now, let's do some others using this factoid. And yes, there's a train. I apologize. What if you have log base a of x? I want to use what I already know. Well, another law of logarithms is if you've got log base a of x, you can write it using a different base, log of different base of x, over log of different base of a. And I'm going to choose natural log because I know how to take the derivative of natural log of x, and natural log of a is just some ugly constant. Let's bring it out front to get it out of our hair. So I have f of x is equal to some ugly constant times natural log of x. I can take the derivative of that. The derivative of that is 1 over natural log of a times 1 over x. There's that ugly constant, just gets dragged along for the ride. Now, well, it's not really pretty. Let's bring it together, and I'm going to write this as 1 over x natural log of a. Why didn't I stick the natural log of a in the front? because you would want that x would get sucked into there, or you'd do something stupid with it. Let's just keep it where it's nice and safe right there. So now we can take the derivative of natural log of x. We can take the of log base a of x. What about the exponential functions? Let's start with e first. Y is equal to e to the x. Now, I need to write it in terms of logs because I know how to deal with logs. I don't know how to do with exponentials yet. But if y equals e to the x, that means log base y is, natural log of y equals x. This I can take the derivative of. We'll use implicit differentiation on the left. We'll say natural log of y. Well, the derivative of natural log of crap is 1 over crap times dy dx equals derivative of x is 1. So 1 over y dy dx equals 1. Now I need to know what dy dx is, so I multiply both sides by y. So I get dy dx equals y. Well, what the heck is y? Y is my original function. So I'm going to replace that y with e to the x. So the derivative of e to the x is e to the x. That's kind of a nice function. We like that one. So if I want to ask you what the 30th derivative of e to the x is, you could say, haha, it's e to the x. What if we have a to the x? Okay, so we need to do some jiggling again. First off, I'm going to rewrite this as log base a of y of x. I know how to take the derivative of log base a of y. We just learned it a couple slides ago. I can take the derivative of x. It's just 1. So let's do it. Natural log base a of y is 1 over y natural log of a times dy dx. Derivative of x is 1. Again, I'm going to multiply through to solve for dy dx. I'll get dy dx equals y times natural log of a. And what's y? Y is a to the x. Sub it back in, and we get our final solution, or final derivative. So in this slide, or this slideshow, you learned, or you saw 4 functions, 4 derivatives, 4 formulas, and here they are. The derivative of natural log of x is 1 over x. The derivative of log base a of x is 1 over x natural log of a. The derivative of e to the x is e to the x. And the derivative of a to the x is a to the x times natural log of a. So now we've got 4 new formulas we need to start and play with. But this